In this project, we're going to learn about exponential functions, how they work, and what are the elements and what do they mean, and also what's exponential decay, and a few applications of both formulas, and which basically are the same formula. And we are also going to explain a few of the implications of using nuclear energy and what happened in Chernobyl, and mention briefly about nuclear energy here in Mexico, and explain how nuclear energy is safe or can be safe, and what do we think about it.
Exponential growth is the rate at which a certain value grows exponentially over time. These kinds of graphs look very different from a linear graph because we can see how they do not have a direct or definite slope, and as the exponent starts getting bigger, the line continues to go up. These graphs are commonly used to measure world population or radioactive decay. The formula that commonly simulates these kinds of graphs is A equals P. These values represent this. P is the original amount, E is the natural logarithm, R is the annual rate, and T is the years invested, and A is the actual amount or the amount that you want to get with the formula.
In exponential functions, the domain is always all real numbers. The range is from 0 to infinite. The horizontal asymptote is y equals 0, and the reference point is 0, 1. And in exponential decay, the domain is from negative infinite to positive infinite, meaning all real numbers. The range is from 0 to infinite, and the horizontal asymptote is y equals 0, and the reference point is 0, 1. While both of these functions are exactly the same, the difference is that in exponential functions, the intervals are always rising, and in exponential decay functions, they're always decreasing. In exponential decay from the left quadrant to the right, and in exponential functions they're also from left to right, but they're increasing, and here from left to right but decreasing.
While in exponential growth, to get a line that goes up from quadrant 2 to quadrant 1, we have that the rate is positive. But in exponential decay, we have that the rate is negative, meaning that it decreases exponentially. It's this equation right here. So it's how a value decreases related to time. And it's commonly used for measuring radioactive decay because scientists use half-lives, which is a measure of how elements start losing its properties, and it can be calculated, for example, to know the ages of dinosaur bones or of ancient rocks that were found. So it's a very commonly used formula, and yes.
Nuclear energy is a kind of energy that do not generate a lot of pollution because the waste it produces, a lot of them are just like water vapors, and that do not pollute the environment as much as factories or other kind of energy. Using nuclear energy can cause several implications, like environment impact because the transportation of nuclear fuel from one plant to another is pollution hazard. And the fuel, once it's used, you can just throw it away because it's very dangerous and radioactive. Also, by using nuclear energy, we generate a lot of wastes, and almost all of these wastes transmit radioactivity. Is it nuclear energy clean energy? Spending fuel has the potential to be hazardous, but as long as the reactors are operating correctly, with no breaches or leaks, there are no directly harmful to the environment. Fortunately, breaches in nuclear cores are already rare, and from technology upgrades to modernized reactors units, things are getting even better. Like if I have an industry that uses nuclear energy, I will make like safe protocol that makes safety this to not generate an accident like Chernobyl accident, where the machine just explode and liberates all the radioactivity. And maybe a very good thing to do is in Laguna Verde, that it's a nuclear plant here in Mexico.
Are you aware that there is a nuclear energy plant here in Mexico? Well, actually, there is. It's in the Gulf of Mexico, and it's called Laguna Verde. There, actually, a lot of electricity from our country is produced, and with all of the healthy parameters and safety measures, it can be actually a new way of having energy without the consumption of oil or petroleum. We have to start moving to this kind of new energies, because once the reservoir of petroleum starts going out and goes into scarcity, we have to have other solutions. It's very nice that Mexico is starting with these kinds of things, and mostly because a great part of the electricity is made there. And as my classmate already said, it's safe if it's used with certain parameters. For example, the personnel that acts there and that works there must be very precise in what they do into moving the certain machinery and everything, because we do not want what happened in Chernobyl to happen again. In 1986, the disaster was that the personnel that were working there in Chernobyl in Ukraine were not really, they were inadequate for the job, because they didn't know how to move or how to really prevent these kinds of accidents that were made by mistakes that shouldn't have happened. They, by releasing a certain gas that wasn't inside the plant, it created a big explosion that got all the fabric destroyed, and a lot of people died. But the great problem of this is that not only the ones that were present in the plant were the ones that died, but these kinds of plants release a great amount of radioactive chemicals into the environment, and using the exponential functions is how it happens. Because when a certain chemical is released in the atmosphere, these chemicals they continue existing for thousands and thousands of years. It's actually calculated that the safe year to go back and live in Chernobyl without having any safety or health problems is around 20,000 years from that year. Because although the level of radiation that the plant must have given away once it exploded, it was very high. But based on the half-lives of the elements that were produced there, they can extend for thousands and thousands of years. However, these chemicals have affected a lot of parts of the world. We could say that maybe Mexico was somehow affected in a very small scale, but not as much as the ones there in Ukraine and in that part of the country, of the world. We have to be aware that when nuclear weapons are used, they release a lot of chemicals, like when the explosion of Chernobyl happened. The disaster that they can cause is that many of the chemicals reach out and expand into very large amounts, and people get affected. For example, the levels of radiation can lead to cancer, or if it's exposed to large levels of radiation, even death. We think that a solution that could be implemented for this is that the plants, at least for nuclear plants, we should have very safety measures in which the personnel acting there is very precise in what they're doing, and also the construction of these plants must be very adequate and exact, because a tiny level of error in a plant like this could lead to a massive scale of damage, as it happened in 1986.
Other uses for the exponential function include measuring the amount of population, or the rate of repopulation increases or decreases depending on the rate, if it's negative or of positive, meaning that R is higher than 0 or less than 0. Another use is to measure the amount of bacteria reproducing at a certain time, or the amount of bacteria that was present at a certain time. And another use is for investments. The formula of exponential growth in two different ways is used for investments, and to know the actual amount and the original and the actual amount that you want to have after the certain rate or the amount of times that it was compounded. However, in the formula that we showed, we only showed the times compounded continuously. However, it is still used for investments.
How did we feel working like this? This project was actually not that hard as the other projects because what we explained is a recent topic and it's actually discussed in the news a lot with Donald Trump and everything. And the exponential growth and the exponential decay formulas are actually pretty easy. So we feel like it was an easy project and we did like it.
And also, it was very fun to get to know other people from other campus because we did it with other campus, obviously. And but also, it was very hard because we all have different schedules, and sometimes it get difficult to work all at the same time. And yeah, but we like it.